Assalamualaikum and good day. Welcome to CMA422 Structural Design. For the first topic, we're going to learn the simple beam design with the material timber. Therefore, for this class, kita akan belajar untuk timber sahaja, untuk design timber beam. When a beam is loaded, the beam has the bending tendency which is measured in Newton millimeters. Okay, for example, if you have a beam, then there's a load acting on top of the beam. Maybe it comes from the roof or maybe it comes from the floor above. The beam has the bending tendency. Dia akan bend lah. Okay, which is kita panggil juga as a bending moment. And it is measured dalam Newton millimeters. In every loaded beam, for example, you have a beam which is simply supported like this. Maybe there's a point load in the middle, okay, a certain critical point at which this bending moment has a maximum value, M max. Okay, if you draw the SFD and BMD, this is the SFD and BMD, this one I believe that you learn in CMA422, the structural analysis. You will get something like this as the SFD, and the BMD you're going to get 1 point, which is the maximum point. Okay, this one we call it as M maximum. This is the formula, typical formula that we're going to use throughout this topic, which is MR equal to Fz. MR here referring to the maximum bending moment, or we can also call it as M max. Tapi untuk formula ni kita mahu panggil dia MR lah. F is a permissible bending stress and the Z is section modulus. So maximum bending moment, as you know, the unit going to be Newton millimeter or kilo Newton meter. For the permissible bending stress, meaning allowable bending stress, it is Newton over mm square. And for the section modulus, it's going to be millimeter cube. So that is the typical formula that we're going to use for this chapter. What is the section modulus? So section modulus is a geometric property of the cross-section used for designing beams and the flexural members. Section modulus is affected by the shape of the beam. Maksudnya cross-section dia, because it has effect upon its strength. The effect of shape is measured in millimeter power of 4, which is moment of inertia ataupun second moment of area. We can get the section modulus daripada value moment of inertia. So kalau masih ingat CMA422, you learn to find the IXX and IYY. So this is second moment area. For rectangular cross section, kita tak perlu susah-susah nak kira ada IXX. We can get the Z with the formula BD square divided with 6. Okay, if you have a cross section that is a solid like this, then you can simply use this formula. B refer to the breadth and D refer to the depth. For the circular cross section, Z equal to pi D cube over 32. This one also referring kepada a solid circular section. Then you're going to use this formula. But for beam, it is unusual to use a circular cross section. Therefore, kita takkan pakailah this formula. Okay, normally it is a rectangular cross section because this is timber, especially then kita akan pakai the rectangle, the cross section. For a symmetrical cross section about x-axis, okay, because we only consider the x-axis when we design for beam, okay, kita takkan kira untuk y punya axis, because beam adalah horizontal member, okay, therefore we only consider x-axis in all our calculation for beam. Symmetrical here, maybe it's referring to the hollow core like this. Maybe you have a hollow core beam, or maybe you have the I-type beam. So it is symmetrical. Therefore, you can use this formula, which you have to find the value of Ixx and you have to divide with y. So y here referring to the distance from the centroid to the bottom or the top lah, since it is symmetrical kan. So this is y. That is the formula for section modulus. Now we look at here about the allowable stress. Okay, sebab formula kita MR equal to Fz. So Z is section modulus and F, this refer to the safe allowable stress. Okay, the material of which the beam is constructed also affect the beam strength, and this factor is measured in terms of material safe allowable stress. Therefore, material ni yang effect juga kepada strength of the beam. So when we going to calculate the strength, meaning bending stress kan, so kita nak tahu how it resists the bending. Therefore, kita kena tengok on the material itself, yang kita dapat tengok apa yang effect daripada material tu, which is the allowable stress. Now we look at the example 1. A timber beam of rectangular cross section is 150 mm wide and 300 mm deep. Then we can draw. This is 150, this is 300. The allowable bending stress in tension and compression must not exceed 6 Newton over mm square. So this one is F, since it is allowable bending stress kan. What is the maximum moment in kilonewton meter that the beam can safely carry? So the question asks you to find the MR. Then kita boleh solvekan this problem. Since we know that our formula is MR equal to Fz, so we going to find the MR. The F kita dah ada. However, for Z here, we need to find the Z here referring to the section modulus. So Z is, since ini adalah solid rectangle, therefore BD square divide with 6. So B here is 150 mm times D, which is 300 mm square, divide with 6. You will get 2,250,000 millimeter cube. Okay, so you can stick with this units, or you boleh tukar kepada meter cube, ataupun kita boleh juga buat dia dalam 2.25 times 10 power of 6 millimeter cube. Dia masih lagi unit dalam millimeter cube. However, kita just untuk memudahkan kita to calculate ya. Then it is better kalau kita buat dalam 10 kuasa 6 like this. We got this 10 kuasa 6. This is 1, 2, 3, 4, 5, 6. So the point dekat sini lah. Therefore, it become 2.25 times 10 power of 6 millimeter cube. Then we can just masukkan dalam our formula here. F, we know that it is 6 Newton over millimeter square. And this Z is 2.25 times 10 power of 6 millimeter cube. 13.5 times 10 power of 6 Newton millimeter. Since ini pangkah, ini tinggal 1 Newton millimeter Okay, so we can leave it like this, ataupun we can convert it into kilonewton meter. Okay. Kalau convert into kilonewton meter, Newton to kilonewton bahagi 1000, dan you akan dapat 13.5 times 10 power of 3 kilonewton millimeter. Okay. And kalau you convert millimeter to meter, you kena bahagi lagi 1000. Therefore, you will get 13.5 kilonewton meter. Okay, that is the final answer. Siap. For example 2, a timber beam has to support loading which will cause a maximum bending moment of 25 times 10 power of 6 Newton millimeter. This one referring to the MR. The safe bending stress must not exceed 7 Newton over mm square. So this one is F. What is the section modulus will be required in choosing a suitable section? So this one, dia akan minta Z lah. Okay, first, keluarkan the formula which is MR equal to Fz, given the value of MR and given the value of F. And we can find the Z by dividing the MR with the F. This is the answer. Now, let's look at example 3. A timber beam is required to span 4 meter. This one referring to the L punya span, carrying a total uniform load inclusive the beam self-weight of 40 kilonewton. This is the load, which is W. The safe allowable bending stress is 7 Newton over mm square, referring to F. Choose a suitable depth for the beam if the width is to be 50 mm. Means that you have a rectangular beam with the breadth of 50 mm and you need to find the value of D. What we need to do first, we need to calculate the maximum bending moment, because we know that we have the formula of MR equal to Fz. So kita kena dapatkan ni. F kita dah ada. Okay. Z that we need to find, because daripada Z we can get the value of D. B 50 mm. How do I get this formula? Max equal to WL square over 8. Okay, remember it says in the question, it says that it is a total uniform load, which means it is a UDL. Means that for the span of 4 meter, the length of the beam, okay, it is uniformly distributed with the load is 40 kilonewton. Okay, ini adalah simply supported beam ya. If you draw a shear force and bending moment diagram, for example, you pun draw lah. It's going to look something like this. Sebab kalau you boleh pakai this formula directly without the need to draw the SFT BMD, if you have the load yang acting on the beam, it is a uniformly distributed load along the length of the beam. Meaning that for 4 meter length of beam, it is all UDL that acting on the top of the beam. Tak ada load lain. Therefore, you can use this formula. No need to draw the SFT and BMD. Kalau you draw, you will get something like this lah. And this is going to be your maximum bending moment, which is inilah dia. You tak perlu nak draw lah the SFT and BMD. You can just use this formula. Okay. Just masuk saja, okay. Ingatlah formula ni. Ini memang untuk UDL, uniformly distributed load. You can get the maximum bending moment. WL square over 8. Okay. Okay, W, this is the 40 kilonewton. Okay, and the length is 4 meter. However, notice that I tak kuasa 2 kan that 4 meter. I just maintain 4 meter dah. Why? Because this load yang acting on top of the beam ni, because according to the question again, dia bagi dalam 40 kN, bukan 40 kN per meter. Means that 40 kN tu normally kalau nampak kilonewton dia adalah point load. Okay, biasanya kalau UDL you akan nampak something like 40 kN per meter. Dia ada per meter ni UDL, betul. Okay, tapi for this question dia mention kilonewton saja without per meter, and it also mention it is uniformly distributed load. Okay, so you know that sebenarnya dia memang uniformly distributed load. It should have the over meter, tapi dia dah tolong darabkan the length of the beam tu untuk you lah for this question. Therefore jangan kuasa 2 kali lagi kat sini. Okay, tengok unit dia, you have to look at the unit first, and you know lah this one dia memang mention it is UDL, tapi unit dia kilonewton. Okay, therefore you know jangan darab kuasa 2 kat sini. Okay, WL over 8 sahaja. Okay, if the question bagi 40 kN per meter, yes, you have to use this instead. So length tu you kena power of 2 kan. If not, then don't. Okay, kalau tak ada ni, tak perlu. Alright. So you can get the maximum bending moment without the need to draw the SFT and BMD using this formula. Then just put the value that you get from the maximum bending moment inside our formula, which this one refer to the MR, 20 kilonewton meter, but we have to convert it into Newton millimeter, therefore times 10 power of 6. Sebab 1 kilo Newton convert to Newton, you kena darab 1000, and meter convert to millimeter, you kena darab another 1000. Therefore, di 10 kuasa 6. And 7 is F. This one given in the question. And Z is the value that we need to find in order to get depth D. Then you get something like this, which is 2,857,142.857. Next, once we get the value of Z, then we can insert into the formula of Z equal to BD squared divided by 6 to find the depth. Just put in the value of Z here. Okay, and B is given, dia dah bagi the width ataupun the breadth of the section, which is 50 mm. And we need to find the D, therefore leave it like that, and power of 2 divided by 6. D is equal to 585.54 according to my calculation. And this is the minimum value. Means that this value cannot go lower than this. Okay, so if you look at the drawing kan, kita takkan nampak orang sebut the size of the beam 50 mm times 585.54 mm. So normally dia akan round up kan to a value yang tepat-tepat. For example here I put 600. This is the nearest. Tak boleh lagi rendah daripada 5. It should go higher. Tapi takkan kita nak cakap the value of D adalah 586. Okay. So 586 tu kita tak pakai that kind of value. Especially bila nak construct or what not. So we're not going to use that kind of value. Normally value dia tepat-tepat lah. Or you can also use 590 pun boleh, as long as it is bigger than this 585.54. It cannot go lower than this value. Okay, even kalau you dapat 585.54 1O sekalipun, this is the minimum Dia ada point dekat sini 1O. Meaning you tak boleh round down dia 585. Macam mana pun you mesti naikkan dia sebab dia dah lebih ni 0.10. Therefore 590 ataupun 600. This one cannot. Okay, that is for example 3. Now, let's look at example number 4. The section of floor shown in figure is to be carried out by 125 mm times 75 mm timber joist. Spanning the 3 meter length, the bending stress must not exceed 4.6 Newton over mm square, and the total inclusive load per meter square of floor is estimated to be 2 kilonewton. At what cross center X in mm must the timber joist be fixed? Okay, for this question, it is slightly different from example 1, example 2, and example 3. In this question, asks you to find the value of X. And what's given here is the floor and the joist. So joist ni it's actually supporting the floor, because basically if we have a timber structure, so if you have a timber floor, then it will be supported by a joist. Joist dipasang banyak lah untuk support bawah timber floor, okay, supaya floor tu tak bend. Kalau tak dia akan bending. You cannot just support at one side only. For example, you just put here one and put here one. Cannot since dekat tengah ni tak ada support langsung, then akan bend lah. Therefore, we do need the support from joist. Okay, so in this question tak ada beam ada joist to support the floor. Okay, now we need to find the value of X. And given here, the joist punya size is 125. Okay, this is the height, and the width, the B, going to be 75. Okay, so as you can see, kalau you dapat soalan about timber ataupun about joist, if they give you the dimension, please take note that the value yang lebih rendah ni akan jadi the breadth, and the value yang lebih besar ni akan jadi the depth. Okay, because the IXX untuk this kind of dimension ataupun this kind of shape, maksudnya dia tegak dia bukan melintang macam ni. This one, this is horizontal, so dia vertical kan. So kalau dia menegak, dia punya IXX lebih besar compared to kalau dia melintang. Therefore, dari segi strength, we can see that if we put the joist ataupun the beam tegak, okay, it will produce higher strength compared to if you put it horizontally. Okay, therefore, it should be like this lah, 75 and 125. The span, okay, which means the length, 3 meter. The bending stress, so this is F. Total inclusive load per meter square of floor means that untuk 1 meter floor ini, doesn't matter lah 1 meter floor dekat mana-mana side of the floor dia can carry 2 kilonewton per meter square. Untuk 1 meter square dia boleh carry 2 kilonewton untuk floor Tapi kita tak tahu size floor ni, sebab kita nak tahu this one joist boleh support berapa banyak load, so that kita boleh dapatkan the value of X. Okay, therefore what we're going to find first is we need to buat some equation lah, okay, in regards to finding the load to be carried out by one timber joist. Okay, we know that the width of the joist is 3 meter. Okay, sebab kita nak tahu untuk satu joist kan. Okay, so we take one joist. Okay, and we know that half of this akan disupport oleh satu joist. Okay, another half, for example like this, okay, it will be supported by this joist, and for this joist it will be supported like half of this, something like this, ya. So yang kita tengah buat sekarang ni is this one lah. Okay, so I tanda satu saja dulu. Okay, sebab kita ambil satu je joist, sebab kita nak tahu untuk satu joist tu boleh support berapa banyak. Okay, so the area should be 3 meter darab X meter. Okay, and we know that untuk 1 meter square dia boleh support 2 kilonewton. Therefore, we going to write it like this lah. 3 meter dia punya lebar floor. The X meter adalah lebar juga, tapi untuk satu joist punya lebar yang dia boleh spread ke satu joist sahaja. The weight tu ataupun the load tu akan di carry oleh satu joist sahaja. And times with 2 kilonewton per meter square. So this is the load that will be carried by one joist, untuk satu joist sahaja. Then we get 6x, which is x ni the things that the value that we need to find untuk satu joist, berapa value x tu. Okay, berapa value lebar yang akan disupport oleh satu joist. Okay, next we going to find, since kita punya formula memang MR equal to FZ. Okay, so whatever it is, if you get any question in regards to timber design, beam ataupun joist, then we know that this is the formula. So we have the value of F, ini memang dapat diberi dalam soalan. Okay, MR is what we going to find later on, and Z is basically what the things that we can find, sebab kita dah ada the dimension of the joist. So this is based on the dimension of the joist. The breadth is 75 mm, the depth is 1 to 5, power of 2 divided with 6, then you get this value. Okay, then we have these two value. However, this MR is what we need to find, the maximum bending moment. Therefore, at the end, we can find the value of X. Right, so just fill in according to the formula of MR equal to FZ. You have the value of F, which is 4.6 given, and Z is the value that you get from the calculation above. Then you get 898,437.5 Newton millimeter. Then you can convert it into kilonewton meter to menyenangkan later on bila you nak kira to find the X tu. Okay, sebab X tu usually in meter lah. Okay, so what you need to do, okay, this is the MX formula again. WL, usually you will see something like M equal to WL square over 8. Okay, when you will know whether the WL square ataupun WL sahaja. When it is related to the floor, okay, since the joist is supported by the floor, dia akan jadi WL sahaja. Because kalau kita tengok floor, masa kita calculate the weight itself, if you notice that, okay, ini adalah okay, for one joist, okay, this is the floor yang dia akan carry. Okay, I just ambil, okay, the length with the X, and length dia is 3 meter. Okay, however, kita tak consider dia punya depth. Okay, so depth ni tak masuk dalam calculation. Okay, kalau normally for floor memang macam ni lah. Okay, therefore when we calculate the weight, kita tak masukkan the depth of the floor. That's why W here dia dah macam ini. Okay, per meter here sebenarnya dia tengah consider untuk the value of X ni sebenarnya, sebab X ni kan dia dalam meter kan. So when we get the value of X, we will get in meter. When it's related to the floor, okay, since kita tak ada darabkan pun dengan dia punya depth, okay, therefore kita akan pakai WL over 8. Okay. Kalau dia relate dengan floor, sebab ini adalah load yang transfer from floor to joist. That's why kita pakai WL over 8, bukan WL square. This is different from the previous example. I think in example number 3 that one is a different thing. Itu memang masih lagi beam, dia tak ada kaitan pun dengan floor, but it just that dia dah bagi uniformly distributed load dalam unit kilonewton. However, this is not, this is because of we are calculating the load that come from floor. Okay, so WL over 8. So L, given the question, it is 3 meter, divide with 8. Okay, Mx is 0.89, okay, from the MR value. Then you will get the value of X is 0.399 meter. Okay, when you get the 0.399 meter, we don't round it up. Okay, since if you round it up, dia akan lebih berjarak. The X here means that this is the maximum value. You cannot go above it. Okay, so kita round down because when we think it logically, bila joist tu, when we put support, lebih rapat, maksudnya lebih bagus compared to lebih berjarak. Therefore, kita round it down. Don't round it up. Different from the previous one, previous calculation masa kita kira beam sebelum ni, when we talk about the depth lebih besar beam tu means that when it is, the beam is bigger, the dimension is bigger, means that it is better. Okay, it provide you better support. However, for jarak, distance between joist, ini sekarang ni jarak ni, okay, satu joist tu boleh support berapa banyak. Okay, so kalau kita consider dia, for example kita ambil 4 meter, so kita dah over estimate sebenarnya. So maksudnya 4 meter sebenarnya dia lagi besar. Dia sebenarnya joist tu tak mampu pun support sampai 4 meter. Dia sebenarnya joist tu sehingga 0.39 meter sahaja. Okay, itu adalah load yang boleh di carry. Okay, done. So this is for question example 4. Next, we go to example 5. For example 5, okay, if the floor mentioned in example 4 has its 125 mm times 75 mm timber joist at 400 mm centers, and the span of the timber joist is half by the introduction of the main timber 150 mm wide as shown in figure. Okay, question A, what load in kilonewton per meter square will the floor now safely carry? We're going to do the question 1 first, but we have to look at what's given in the question. Okay, so for example, this example is related to example number 4, since you see here value of the size of the timber joist is the same. Okay, however, it says here benda yang lain adalah tadi kita dah measure, kita dapat 0.39 meter, kita round it down. Okay, however kat sini dia letak 400 mm, then just follow this value for this example. It means that, okay, for one timber joist, okay, can timber joist at 400 mm centers, meaning that semua ni 400 lah, 400, meaning one joist ni, so lebar dia tu adalah 400. Tapi sekarang ni in this situation, dia dah letak one main beam at the center. Okay, warna merah ni, this is one main beam, meaning the timber joist ni jadi half je, separuh, and they sit on the beam. Okay, and the other half is separuh lagi dekat sini, and separuh dan separuh seterusnya. But right now we are looking at one timber joist only. Okay, however in this question, soalan dia is related to kilonewton per meter square. Now this floor now safely carry. Okay, why this is different from the previous one? Previous one tak ada introduction of the, therefore the timber joist will span for that 3 meter long tu tadi, panjang 3 meter, sepanjang-panjang ini. However, when there is an introduction of the timber beam, okay, the span is half lah, which is 1.5 meter. Therefore, we need to calculate again, bukan lagi 2 kN per meter square, sebab sebelum ni dalam our example number 5, this for 1 meter square, the floor can carry 2 kN. Okay, however, this question with the introduction of the main beam, dia dah jadi value dia lain. First, we need to do some equation to find the load to be carried out by one timber joist. Okay, since what you trying to find adalah the value of y, sebab macam tadi kita mencari value of this one, which is the x, but this time around you're going to find the value of y with the introduction of timber beam. Okay, then you get 0.6 y meter square. 1.5 here referring to this one. Okay, since the span of the joist dah jadi separuh, half of the actual length yang sebelum ni 3 meter, so sekarang dah jadi 1.5 meter. Therefore, it is 1.5 and 0.4 it is given in the question here. So each timber joist ni span dia adalah 400, which means like this is 400. So it's almost the same lah. Sebenarnya kalau kita bagi separuh pun, satu timber joist akan carry 400 width dia lah, and then the span adalah 1.5, and untuk satu timber joist ni boleh carry berapa banyak kilonewton per meter square the load untuk 1 meter square berapa kilonewton. That's what we're trying to find. Okay, now you kira macam dapatlah this value. Next, we're going to find the value of Z. So Z for timber joist is the same. Okay, timber joist sama saja, because soalan ni minta untuk 1 meter square floor can carry. Therefore, kita akan pakai the value of Z untuk timber joist. But timber joist ni yang carry the floor dulu, lepas tu baru with the support from the beam. Therefore, kita tak akan kira Z of beam. Right, so sebenarnya timber joist kita, because this is according to example number 4, therefore the value of Z sama, and when we calculate the MR pun sama, since F masih lagi 4.6 according to example number 4, and the Z, which is the section modulus for the joist, masih sama since the dimension sama. Then you get this value, tukarkan dalam kilonewton meter. Right, so next, okay, we're going to find the value of y. So using the formula of M maximum. Okay, since kita memang tahu when the floor dia nak transfer to the joist, it is uniformly distributed load. Okay, dia tak akan jadi point load. Kalau load daripada beam to column, yes, it is a point load. However, daripada floor transfer to the joist, memang it is uniformly distributed load, sebab load dia sama je untuk sepanjang-panjang joist ni. Okay, right, you will get formula macam ini, Mx sama WL. Sama juga L ni kita takkan kuasa dua kan, because this one we are talking about the floor. Sebab floor it is tanpa kiraan depth. Kita tak ada darab depth pun dekat dalam our calculation for W here. Therefore, we cannot pakai WL square over 8. Okay, sebab ini adalah kaitan dengan the floor. Masukkan je the value yang kita dapat, M maximum. We have it here, which is the MR. The 0.6Y adalah W. Okay, this is the load yang have to be carried out by the timber joist untuk 1.5 meter darab 0.4 meter size itu. Okay, tapi berapa untuk 1 meter square? That's what we're trying to find, this Y. And 1.5 adalah the L length, which is tadi 3 meter. So with the introduction of the beam, dia dah jadi half of it, which is 1.5 meter. bagi dengan 8. Then you will get 7.98. Sorry, tertinggal. 7.982 kilonewton per meter square. For my calculation, I insist to use 3 decimal places instead of 2 sebab dia lebih tepat. Kalau you pakai nanti 7.98 kilonewton per meter square, so this is tak kurang tepat lah. Bila kita kurangkan the decimal point, it will be less accurate. Therefore, I insist on 3 decimal places for every calculation. Ini adalah our final answer. So for 1 meter square, it can support as much as 7.98 kilonewton. It is much bigger to compared to the previous without the introduction of the beam. Okay, sebab kalau without the introduction of the beam, the load that can be supported is 2 kilonewton per meter square. With the support of the beam, okay, it can support much bigger load, which is 7.98 kilonewton per meter square. For example number 5, we have question B. What will be the required depth for 150 mm wide main timber beam if F is 5.25 Newton over mm square? Okay, this one, since the introduction of the main timber beam, we need to find, the question asks you to find the depth. Since given here, the width of main timber beam is 150. Given the value of F, so the bending stress, the permissible bending stress is given. Okay, what we need to do first is we need to find the load to be carried out by the main timber beam, because we know that the load will be transferred from the floor to the joist and to the beam. However, since there is a main timber beam, so the joist length become half since transfer load dia tu dah jadi separuh joist dah. Okay, since this is should be like this. Dia dah ada introduction ni kan of timber beam, therefore joist ni transfer load dia dah jadi half. For one beam ni akan support separuh je dari sini, and joist ni dah jadi half lah since ada main timber beam yang akan carry. As for the solution here, okay, as you see, the 4 meter come from the length of the beam. Means that panjang beam tu lah. Okay, dalam soalan pun given yang panjang dia adalah 4 meter. Okay, since beam ni melintang kan, so panjang tu maksudnya panjang floor tu sendiri. And we have to times the 1.5 meter, which is half of the length, since the introduction of the beam, which caused that dia jadi separuh saja. Okay, it's no longer 3 meter. Without the timber beam, when you calculate the load, you have to use the 3 meter length since dia akan 3 meter lah, dia akan transfer sebab joist tu panjang dia dah 3 meter. But bukan panjang joist lah, actually panjang floor ni. So joist dia pun memang sepanjang-panjang 3 meter tu dia transfer to the joist. However, since beam ni ada kat sini, okay, therefore dia akan ambil half of the floor. Should be like this Jadi dia akan transfer like this. Okay, what about the other one? So should be, kalau kat sebelah sana mungkin ada another beam lah to transfer the load Therefore, but for this question, kita akan tengok untuk this one, main timber beam. Okay. And samalah kat sebelah sini pun, that's why dia jadi 1.5 meter instead of 3 meter. And then you times with the 7.982 kilonewton per meter square, because this is the one that you calculated previously masa you kira the value of for 1 meter square berapa load yang akan transfer. Okay, maksudnya berapa loading daripada that floor dia akan transfer. Okay, it is 7.982 kilonewton per meter square. So you dapatkan value berapa sebenarnya, okay, untuk 4 times 1.5 meter square. Okay, so you akan dapat 47.892. Next is calculating the M maximum. Okay, so WL over 8, because this one, as you remember, like I said previously, kita tak perlu kuasa 2 kan dia, since this load come from the floor. Okay, so bila dah come from floor, tak ada kaitan dengan the depth. So that's why kita tak perlu darab WL square ni. Okay, so WL saja over 8. So length dia 4 meter lah, which is the length of the beam. Okay, divide with 8, then you dapat the value of M max. We're going to calculate the value of Z sebab kita nak dapatkan the depth, which means Z is the one that we need to find. So M maximum that we get from here, we just insert into this formula, and the F for the beam is given the question, which is 5.25, which at the end you will get this value. Right, so we need to find the depth. So in order to find the depth, we can get the depth by using the formula of Z equal to BD squared divided with 6. Okay, this is the formula for section modulus rectangular beam, solid rectangular beam. Then you just put the Z here, okay, the value of Z, and the B is given in the question. Then what you're trying to find is the D. Okay, so you just 4,561,142.857 times 6 and divide with 150, and you square root kan the value of D, you will get this value. Okay, so when we get this value, as what I mentioned previously, the higher the better kan. I mean, lebih besar lebih bagus. Maksudnya lebih tinggi lebih bagus, lebih lebar lebih bagus. Okay, so when we get 427.137 means that this is the minimum value. You cannot go lower than this, so you can round it up. So I round it up to 530 mm. So that is our final answer for the example number 5. Now let's do exercise number 1. Okay, a rectangular timber beam of 100 mm times 200 mm. Okay, remember the smaller value will be the width or the breadth. Bigger value should be the height or the depth. Is simply supported over a span of 3 meters. This refers to the length, and carries a uniformly distributed load throughout the whole span. Okay, it is uniformly distributed. If the permissible bearing stress of the beam is 12, so this referring to F, determine the maximum uniformly distributed load per meter length that the beam could safely carry. Means that what it's trying to find is the nakkan value of W, which is maximum uniformly distributed load per meter length. Now first, what we can do is we can find the Z, basically because you know the formula of MR equal to FZ. So this is apa yang kita cuba cari lah. Okay, so since F dia dah bagi, and we can find the value of Z since the dimensions of the beam given. Okay, so using this formula you can get the value of Z, and you just put it inside the formula of MR equal to Fz. Okay, F12 Z is as per our calculation of Z. Okay, then you will get the value of maximum bending moment, the MR. Then what we do next is we just have to find the value of this W. Okay, so W here referring to the maximum distributed load, uniformly distributed load. Okay, so W here sebab kita pakai formula WL square over 8, so we know that along the beam, okay, since it's also stated in the question, the load adalah uniformly distributed, so that's why kita pakai WL square over 8. Okay, here notice that I put the L here because it got nothing to do with the floor. Sebab kat sini kita tak cakap pasal floor, it just the beam. Okay, jadi bila kita cakap pasal beam, directly you know that bila question to you specifically ask, dia nakkan maximum uniform distributed load per meter length, meaning that per meter untuk 1 meter beam. Okay, berapa banyak yang beam tu can safely carry, means that kalau load it is kilonewton lah. Okay, so berapa kilonewton per meter, that's what you're trying to find. So you just put the value of MR here. So notice that I convert into kilonewton meter since kita nak stick to one unit saja. Maksudnya kalau kilonewton kita kena kira semua dalam kilonewton. Kalau kita pakai meter, kita kena kira semua pakai meter. Tak boleh kilonewton satu lepas tu tiba-tiba nak masuk newton pula. Tak boleh. So kalau dekat sini you can actually boleh pakai je value newton millimeter with no problem. But make sure that here kalau kat sini millimeter, make sure the length ni pun you kena tukar tu millimeter. You cannot simply campur-campurkan dia lah. Okay, that's not how mathematics works. So kalau length kita pakai meter, stick to meter. Kalau kita pakai millimeter, stick to millimeter. Kalau kita pakai for area, kalau kita pakai meter square, dah stick to meter square. Kalau kita pakai millimeter square, dah stick to millimeter square. Tak boleh meter with millimeter. Cannot in one equation. What we try to find is the W. Okay. So 8 kilonewton here I tukar. I convert into kilonewton meter. Bagi 1000 for newton, tukar to kilonewton. And bahagi lagi 1000 for mm, convert to meter. And then for the length, okay, since it is given that the L, the span, it says here, it is 3 meter. So we know that that's referred to L. L is 3 meter and I kuasa 2 kan, divide with 8. Okay, dia tak ada related dengan floor, therefore kena kuasa 2 kan. Alright, and then bagi dengan 8. Then I will get 7.111 kilonewton per meter. Because soalan ni specifically dia cakap per meter. Sebab dia nak dalam per meter. Okay, per meter length. Kalau dia tak ada mention per meter length, okay, you can just stick with M equal to WL over 8. Kalau dia nak dalam kilo Newton saja. Specifically mention that the maximum uniformly distributed load per meter length. Untuk 1 meter lah, kan. So, per meter. So, untuk 1 meter berapa the uniformly distributed load. Therefore, that's why L ni kena, you have to kuasa 2 kan dia. Kalau dia tak ada mention per meter, it says that determine the maximum uniformly distributed load that the beam could safely carry, which means that you can also jawab dalam kilo Newton without any problem dan tak perlu kuasa 2 kan. Tapi kalau dia mention specifically per meter, then you have to kuasa 2 kan di sini. Okay, this is not kuasa 2 dekat sini tak related langsung dengan as per our previous example lah. Kalau anything yang related dengan the floor, the reason for kenapa kita tak letak kuasa 2 tu lain. Okay, sebab kita tak consider the depth of the floor masa kita calculate for the load. Sebab itu adalah untuk floor. Okay, tapi because of this one specifically mentioned about the beam itself, it got nothing to do with the load transfer that coming from the floor. Therefore, the reason why is because of what's actually the unit that this question wants you to answer. Now we're going to look at exercise 2. The timber box beam shown in the diagram spans 6 meter and carries a uniformly distributed load of 2 kilonewton per meter. Means that this is W, this is length. And centrally placed point load of 3 kilonewton. So you have another load which is point load. Determine the maximum stresses due to bending. Okay, maybe I tak mention lagi sebelum ni. Kalau tadi I cakap kalau UDL, okay, when you get UDL, when you draw the SFD and BMD, so I said that the maximum value here, you can just simply use the formula of WL square over 8 to get the maximum bending moment for your BMD, bending moment diagram. And kalau point load, for example, have point load like this, okay, at the center also, the point load, then you will draw this, the SFT will look like this, and the BMD will definitely look something like this. Okay, so for here, this value adalah WL over 4. As simple as that, you can just use the formula to get the maximum bending moment. Tak perlu nak draw. Kalau dia just a simply supported beam and it is centrally placed point load, you can just use this WL over 4 to find the maximum bending moment. The first thing what we need to do is we need to get the value of M maximum. Okay, because whatever it is, we know that we need to use the formula, this formula. Okay, since this question dia minta apa? Dia minta maximum stresses due to bending, meaning this question want you to find F. Okay, therefore you need the value of MR, you need to find the value of Z. Okay, so for MR, inilah yang we trying to find with the Mmax. Okay, since dia dah cakap, this question specifically mention dia ada uniformly distributed load along the beam, okay, which is span 6 meter, and a centrally placed point load, meaning a combination of UDL and also point load at the center. Therefore, we can simply use WL square over 8 for the uniformly distributed load and WL over 4 for the point load. Kita just boleh tambah je macam ni. This one for UDL and this one for point load. Right, so just isi je, okay. You know that the W for the UDL is 2 kilonewton per meter, okay, times 6 meter, which is the length, the span of the beam. Power of 2 divided with 8 and plus 3 kilonewton times 6 WL over 4, so bagi dengan 4, then you get this value. Okay, that is for the Mmax. Okay, next we need to find the value of Z lah. However, this is not your typical rectangular, solid rectangular beam. Okay, this is the beam with the void. This is timber box beam. Okay, so ada void dekat tengah-tengah ni. Okay, so what we need to do is we need to find the value of IXX, since we know that the formula untuk dapatkan Z for any symmetrically x-axis beam, okay, we need to use this formula instead. Okay, IXX divided with Y. So the shape of the beam is ada hollow section, so kita akan ambil IXX di luar, yang maksudnya kotak besar, tolak dengan hole yang dekat dalam lah, which is the kotak kecil. Dan kita boleh dapat cara lebih mudah lah daripada you nak kira macam you belajar masa sebelum ni kan, you ada bahagikan this is 1, this is 2, this is 3, this is 4. Itu cara lambat lah. Apa yang kita boleh buat, kita boleh ambil this one whole box, okay, yang besar, minuskan dengan hole yang dekat dalam. Since it is symmetrical, we can use this cara to get the IXX. For IXX, the kotak luar is 120. Okay, dia dah bagi the price is 120. Okay. And the depth is 450. Okay. Therefore, 120, 450 cube divided with 12. Because you pun tahu kan the formula for IXX is BD cube divided with 12 plus AH square. However, AH square ni kita takkan kira lah, since dia tak ada value of H. Okay, sebab dia center, dia symmetrical. Okay, and kita ambil dia as a one whole rectangle. So, bila one whole rectangle, kan dia punya centroid dekat sini. So, the distance tak ada, since the centroid of section yang kita kira kat sini, and the centroid of the whole section pun memang dekat tengah-tengah. So, obviously, there is no H. Okay, when there is no H, so tak adalah So tak payah kira lah. Okay. This is for the outer box. Okay. So at the box at the inside, it is 96. So the breadth is 96. You can just use 120 and minuskan dengan 12 mm for it should be like this. Ini 12 mm and this is also 12 mm. Okay, inilah dia. So 120 tolak 12 tolak 12. So you dapatlah berapa lebar ini. And di sini the depth for kotak kecil ni should be 450 minus 50. Okay, and minus 50. You get 350. So this is for the kotak kecil. Okay, and you just calculate, you get this Ix, X, and if you still remember Ix kita memakai dalam darab 10 kuasa 6. Then we get the Ix, we can calculate the Z. Okay, so Z or Z is Ix divided by Y. Y is Y, so Y is the distance from the centroid to the bottom or the very top. Doesn't matter since they're symmetrical. So separuh daripada that the height of the section. Okay, sebab height of section is 450 kan. So separuh adalah 225. Okay. Kan, ini kan sebesar-besar ini. So ini 450. So you just take from the center. This is the half of it, which is 225. Then this is the value of Z. And finally, you can calculate the value of F by filling this formula. The value of MR you dah ada, which is this one. And we have the value of Z. Then you can get the F. Alright, so we are done with the exercise 2. Let's move to exercise 3. Part of timber floor plan as shown in figure is subjected to imposed load of 5 kN per meter square and dead load of 3 kN per meter square. So both of this is W. We also notice that this is a uniformly distributed load, both of it. However, one is dead load and another one is imposed load ataupun live load. Okay, determine the depth of the timber joist if the width assumed to be 300. Therefore, the width is 300. What is the depth? An allowable bending stress of timber is 10 Newton over mm square, which means this is F. So what we trying to find? We trying to find the value of D, which means that we need the value of Z. So kalau kita guna formula MR equal to Fz, then we can get the value of MR, we can get the value of F. However, we need to find Z in order to find D. Load to be carried out by one timber joist. Maybe you are slightly confused. Okay, what is 1.35 GK? What is 1.5 QK? So QK here referring to the live load. Okay, ataupun imposed load. And GK here is dead load. For timber structure, okay, 1.35 here, this is referring to factor of safety for dead load. Okay, and 1.5 here refer to factor of safety for live load. Sebab kalau kita design, we need some buffer. So buffer ni adalah factor of safety, maksudnya lebihan. Kita tak boleh betul-betul design 1.0. For example, kalau kita campur je dead load campur live load, so that is the load. Okay, basically when the question give you separate value, one is live load, one is dead load, and then you need to times the factor of safety. This factor of safety definitely it depends on the environment also. Okay, sometimes if there's a wind that might affect the structure, then we need to consider also for the wind load. Okay, but here we can expect this is the normal ataupun adverse. Kalau it is for concrete, maksudnya RC, reinforced concrete, dia punya factor of safety lain. Okay, but this is the factor of safety for timber. This is according to the British standard. So bila kita design, kita akan pakai British standard ya. Ataupun mungkin ada orang pakai Eurocode, but in Malaysia definitely Eurocode memang dah implement, tapi penggunaannya masih kurang, jadi kita stick to the British standard So 1.35 GK is given, which is the dead load, and this is the value of QK. Ini factor of safety tadi, must stick to it Okay, and then we times with the area. Okay, so one timber joist will carry as much of this which is, this is 5 meter, and this is 2 meter. Okay, therefore 2 meter times 5 meter, that is the area. So you get 5.175 kilonewton untuk area sebesar 2 meter darat dengan 5 meter. Next, we can get the value of maximum bending moment, sebab kita nak masukkan dalam formula MR equal to FZ kan, because we need to find the value of Z, sebab kita nak dapatkan D. So MR kita boleh dapat, which is MX, WL over 8, because this is related to the floor. So remember, you don't need to power of 2 kan L tu. Okay, so 5.175 kilonewton times 5 meter, which is the length of the joist. Okay, panjang inilah. Bagi dengan 8, then we get the value of M maximum. Then we can get the value of Z. Sebab kita nak dapatkan value D kan. Okay, so Z is equal to BD square divided with 6. So B is 300. D square bahagi 6. So kita dapat 50 D square mm. So kita nakkan value of D. And kita boleh just insert dalam the formula of MR equal to FZ. Since we know that the MR is 3.234 here. Tapi look at here, I convert into Newton millimeter sebab kita kena stick to kalau kita pakai Newton, kita kena stick dengan Newton, tak boleh kilonewton dan Newton sebab we must remember that the value of F yang given dalam soalan ni adalah dalam Newton millimeter square. Okay, therefore, okay, bila ini dah Newton over mm square, make sure that everything here, okay, 1 is Newton, 1 millimeter. Okay, kalau millimeter, millimeter. Okay, so convertkan dia, kilonewton to Newton times 1000, meter to millimeter times another 1000. That's why there is 10 kuasa. And the F, so 50 D square mm. Okay, and you can get the value of D by just 3.234 times 10 power of 6 bahagi 10 and bahagi lagi 50. And then you square root kan, you akan dapat 80.442. So kita tak boleh stick to this value lah, and we cannot round it down Remember, the depth lebih panjang, lebih tinggi the height of the beam tu, the depth of it, so it is better, lebih besar beam tu lagi bagus. So make sure you round it up. So I round it up to 85. Okay, so that is my final answer. Okay, that will be all for today's recorded video. Thank you so much and have a nice day.